Hi there, welcome to our very last class of our food chase training. Today we'll be working and studying on the module number 10. I really hope you have reached this point content and happy, and I really hope that the content that we have put together for you to train has been served you and has been serving you as a positive document along your technical formation. Let's start our class of today's class. The learning outcome of the 10th module will be basically these represented by those 5 different bullet points here. Remembering that by the time limiting, we have no more than 25 minutes this class. So we're looking at touching bases, just sharing with you some of the main ideas, and always remembering you that all the written material will be the basics for you to learn more and dive deeper into each of the subjects we will be touching here. Okay, let's start. So by the end of this module, students will be able to apply climate resilient farming practices, understanding how it can actually reduce crop losses under variable weather conditions, implement processing strategies that enhance resilience and climate-induced variability in raw materials, integrate preventive approaches across production and processing to reduce food loss, assess how resilience-oriented practices improve efficiency, stability, and sustainability, and align climate-resilient techniques with the European Union Farm-to-Fork strategy, Green Deal, and climate adaptation goals. You will see over those many different outcomes that we are always looking at decreasing the loss of food and improving the processes, okay? So as an introduction of this module, which attends for the title of Climate Resilient Farming and Processing Practices, climate change is reshaping how food is produced, processed, and distributed. You, as a student, you might probably you have seen that some regions of Europe, they have a shifting climate, which actually is driving and has been driving for the very last 5 to 6 years, the way grains are produced, the way dairy is produced, the way fruits are produced, by changing not just the location, but the timing of it. Because we starting to understand now the patterns of this climate changing and how it influences on the way we produce. And that's why we started the introduction of this submodule with this climate change reshaping. Reshaping is a very specific word, it's a very strong word, and I strongly advise you to read more about how the food is actually being reshaped, the way we produce it, okay? Just following up, rising temperatures, erratic rainfall, and extreme events increase variability in crop performance, harvest timing, and raw material quality, challenging both farming and processing system. Okay, within EU, climate resilience has become a core operational requirement, not an optional adaptation. Remember, it's a core, it's a need, linking food loss reduction directly to climate adaptation strategies. Okay, this is a bit of a schematic I have shared with you, remembering all the links to those graphics and those figures are at the bottom of the page of this presentation, which will be shared with you. And this just explain the political and socioeconomic context of how the dimensions of capacity, such as individual, organizational, system, they are interrelated, and how we can use this way of thinking to understand the impacts, okay, of the climate on the food, okay, on the food production. And there is a statement for that. Resilience moves food system from reactive responses to shocks. Remember the difference between reactive, okay, toward preventive system level design. Remember, you have a reactive, you just act after the problems is set up, and then you move toward the preventive. Actually, before the problem happens, you act accordingly. And not just thinking about the way to fertilize my crop, the way to harvest, the way to process. Actually is a system level design. You know, improve from the seedlings selection to the way I'll be processing the food online. Okay, climate resilient practices strengthen both biological components such as soil and crops, and technical components such as processing, storage, and storage, reducing vulnerability across the value chain. Remember, you have this expression here, value chain. We're not just looking at the soil anymore, not looking at the apple or the orange anymore. We're looking at the value chain, okay? Climate resilient farming techniques, introduction as an objective here, minimize crop losses by increasing the capacity of agro-ecosystems to absorb climatic variability. How you do that? Soil and water management, crop diversification, and adaptive plant selection. Let's check one of those. Soil and water management for climate resilience. Healthy soils, there is a definition for healthy soils. Go and read that, that's very important. Healthy soils buffer climatic extremes by improving infiltration and water retention. Remember, the way the soil receives the water, the way it infiltrates, but most important than that, you must retain it. Okay, some part of this water that has been infiltrated will be evaporated, but some part must be retained by the plants and the root zone and for the water cycle. If you have a healthy soil that's more balanced, you have a more capacity of infiltration and retention. Okay, reducing erosion and runoff during intense rainfall. Remember, runoff is the act of the water on the surface runoff. The water takes the first layer of the soil, carrying all the goodness of the soil, such as minerals, fertilizers, and organic matter. Okay, a healthy soil reduces erosion and runoff during intense fall because it has a better and strong structure. Other thing, lowering evaporation during droughts. You have, if you have a high levels of organic matter, remember, organic matter is the top one substance or type of substance for water retention. It can retain many times its own weight. That's why we lower the evaporation during droughts. Okay, if you have a higher and more healthy soils, and more healthy soils tend to have more organic matter. It's a type of indicator of a healthy soils, the amount of organic matter. Okay, key practices to keep this soil alive, to keep the soil health: conservation tillage, reduced soil disturbance, maintenance of soil organic matter, controlled traffic, and improved drainage. Specifically, those three first bullet points, conservation tillage, reduced soil disturbance, and maintenance of soil organic matter, is under the umbrella of what we call the conservation agriculture. There is a tip for you guys. Type on Google and see Principles of Conservation Agriculture by FAO, Food and Agriculture Organization. That will give you a technical view of what does it mean: conservation tillage, reduced soil disturbance, maintenance of soil organic matter, crop rotation, and etc. Okay? Soil health is a biophysical foundation of a climate resilience. It's a very strong sentence and it's very meaningful. Okay? The next slide goes about, it's related to the chapter of irrigation efficiency and water stress management. Climate resilient water management includes, it's not limited to, but includes precision irrigation methods to crop demand. If my crop demand X, why should I be watering X plus 10? No. Understand how use, Sensor guided scheduling. If you have a water sensor or humidity sensor at the soil level, you will be able to understand when your crop will be needing water, instead of losing water for runoff, losing energy for irrigation, actually using the right amount of the water on the right time, with the right way. Okay? And the third bullet point, drip and low loss delivery system, such as drip irrigation, such as rice production, that's AWD, the way they use the watering on the different levels of the paddock, is always those techniques being thought to be promoting a more efficient way of water, use efficiency of water and energy. Okay, combining soil. Just read this sentence. Combining soil water holding capacity. Remember the healthy soil, the chapter before, with efficient irrigation. You have two different things. You have a stable soil, a better irrigation model, better irrigation practices, reduces drought-induced yield losses, and improves water productivity under climate stress. That's amazing. Okay, this schematic here is one of I have taken it from MDPI Journal of Technology. Is a journal, is a paper, scientific paper. that just describes one of the technical Internet of Things and applications for the water management. And it's actually talking, this paper is talking about one of the potential systems, how it's positive for water and irrigation efficiency and management. Okay, so the link is at the bottom of this page, you'll be able to access. The next chapter, crop diversification and adaptive plant selection. The next chapter is related to the crop diversification and adaptive plant selection. Diversified system reduce systemic risks by, remember, the way we diversify our production will be reflecting directly on our own capacity to cope with the shocks, environmental shocks, market shocks, price volatility, and etc. Okay, just a quick example for you here. Diversified system reduces systematic risks by distributing climate exposure across the species and varieties, improving soil structure and biological regulation, reducing pests and disease vulnerability. Imagine that you have a more diverse crop, such as this figure that I have taken from a scientific paper from a journal that explains the benefits of actually this specific system here, okay? And this just proves that diversification is so important. Just a quick example of reducing pests and disease vulnerability. One pest that's actually adapted to the corn won't be adapted to the other crops. So the natural enemies here will be actually self-controlling, auto-controlling themselves. That's an important thing. The key approaches, crop rotation and intercropping. This is one example of intercropping here. Climate-adapted varieties for heat, drought, and flood tolerance. Okay, different root zone, different topsoil, different water demand, different light demand, different soil demand. Okay, staggered planting dates, not just planting on the same date, but trying to have a different staggered date of planting, different calendar, scheduling, I mean. Integration of perennial and deep-rooted species. Remember, the roots, the depth of the roots will determine where the plant will be actually exploring the nutrients, and at the same time, what type of microorganisms this plant will bring to the system the other one will not bring. So they complement each other, okay? And the last sentence, diversification transforms resilience into a structural property of farming systems, okay? The next chapter, climate resilient processing techniques. The objective of this is to focus that reduce food loss by adapting processing system to variable raw material characteristics. The focus area here, focus areas, flexible processing systems, adaptive post-harvest handling and storage. Flexible processing systems, okay? This is just touching with you the ideas here. Climate variability affects raw material through changes in size and maturity of the fruits, example, easy to understand, easy to relate. Moisture content, that's very clear, and composition and density, okay? Resilient processing systems adjust cutting, one example, some of the examples, not limited to, but some of the examples. Adjust cutting, heating, drying, and residence time. Use adaptive parameter control. You know, as the climate's changing, the way fruits are growing is changing, you need some adaptive parameter control, okay? And the market itself changes as well. The taste of people, they change. So as they change, methodologies must be changed as well to attend the demands, okay? Both the demand from the end consumer and the challenge from the environment, okay? Apply advanced sorting and grading technologies. You have touched that, it's important. Employ modular and reconfigurable processing lines. That's very important because you must be able to attend and to process fruits with a different standards sometimes. And that's why we need some modular and reconfigurable processing lines, okay? Flexibility absorbs variability instead of converting it into waste. Remember, if you have a line that's actually fixed and you have received an apple that's actually too big for that, instead of this apple going rotten or going astray, going waste, if you have a modular processing line, you can actually adapt it and make use of such an apple that's oversized or maybe small size, okay? And this schematic here is from another paper that just shows the food system and the way the food's produced and how it affects our health, well-being, and the environment, and shows, you know, the different cycles from the logistics all the way to the packaging and back to the end user, okay? Starting from the fruit production all the way to the waste streams, okay? Next slide, adaptive post-harvest handling and storage. Key climatic resilience post-harvest practices include, these are not limited, but include rapid cooling and temperature stabilization, improved ventilation and humidity control, segregation of stress affected and damaged products, real-time monitoring and storage conditions. These measures slow deterioration. It not avoids, but it slows deterioration, suppress microbial growth, okay? Do not eradicate, but suppress, and extend shelf life under climate stress, okay? And there is another schematic just stating how important it is to harvest at the right time, okay? And how to actually monitor and use your time in behalf of you, using your time as the main component that will be helping you, okay? Integrating farming and processing resilience. Climate resilience is strongest when farming and processing are coordinated. Integrated strategies include synchronizing harvest timing with processing capacity, sharing climate production and quality data, flexible contracts and logistics arrangements. Remember, sometimes your food is ready, but the market does not accept it. You must have flexible contracts and logistics arrangements. You're not just because of your crop production as well, that means that you're going to be putting. You need to understand the markets, okay? Buffer capacity and redundancy planning, very important. And the value chain integration prevent losses from shifting between stages, okay? When you integrate, like the value chain here, you have something more synchronized. They work accordingly, you know, they are more equalized, and the results will surely be different, okay? Here are some of the pillars of integrating farming, processing, and resiliency. Crop rotation, no-tillage agriculture, soil microbe, and farmyard manure. These are all to enhance soil productivity that will help your system to be more reliable on the climate shocks, that will consequently produce a better produce and help you by receiving a better quality product. And when you integrate it into your system, have something the way stronger, okay? The way better product. The value chain coordination and data sharing. Digital platforms enable shared situational awareness. Remember, from the soil problem to the storage, anticipation of variability, joint decision-making across actors, okay? Farmer, retailer, consumer, you know, joint decision-making across actors. Adaptive contracts and diversify the source and distribute climate risk, stabilizing supply and reducing systemic food loss and uncertainty. Uncertainty will always exist in a climate-changing world. And everything we do, such as coordination or integration of systems, will help us actually fighting it back, okay? Benefits for efficiency and sustainability and food security. Climate resilient systems deliver reduced crop failure and post-harvest losses, improved efficiency of water, energy, and inputs, greater consistency in supply and quality, the market requires that, enhanced resilience to climate and market shocks, okay? These outcomes directly support EU Green Deal and farm-to-fork objectives, demonstrating that resilience, efficiency, and sustainability are mutually reinforcing. This is very important here. This pyramid, this triangle here, just represents the different phases and the impacts of it. Source reduction, reduce food losses and waste. Redistributed, reprocess, feed hungry people. Recycle, feed animals, and composting. Some problems and solutions. Recover energy, nutrients, incinerations, and landfill. You see that just go to landfill when you pass all those steps before. Source reduction, redistribution, recycle, recover, okay? This was our last module, the module number 10. As well, we needed a 10-hour class to explore this, but the main idea of this module of having 15 to 20 minutes class was to pre-introduce you to the topics that will be touched on the written material, the things that will be touched on the exercise to fix the knowledge. I really hope you have enjoyed the food chase training and that you take the best of it. Don't forget to read the papers we have shared. Don't forget to exercise, to make the exercise, and do not hesitate in getting in contact if you have any questions or any ideas. I hope you the best for your career, and I hope you have enjoyed such a training. Thank you.